Hello everyone, here we have application of normal distribution. Okay, and this part is a probability density function showing with PDF. And here on this part we have two factors. The first one, total area is equal to 1, and here on this part height is greater than or equal to 0. So total area also means proportion and probability. So probability is equal to 1 or 100%, and here height is greater than equal to 0. Okay, so the area under the graph of density function or an interval represent the probability. And here the first one is uniform. We're gonna cover this in this part. So we have this one. We also have normal distribution, but I don't have this exponential in this chapter. Okay, now what we have here is exactly what is on this one is uniform distribution. And we want to find the probability or area for this part. Okay, so first step, finding, okay, we have these 2 points A, B. So finding the distance between these two as B minus A. And here we have 1 divided by B minus A. So finding area is equal to length times width, and that is equal to B minus A. So this is L and this is W. So multiply by 1 over B minus A. Simplify B minus A divided by B minus A. This is equal to 1. So the area for what we have inside is equal to 1. Okay, now example. Example number 1, the reaction time X, that is in minutes, of a certain chemical process follows a uniform probability distribution with X between 5-10. Part A, draw the graph of density curve. Okay, so our X is between 5-10. But this is exactly the same as having that one A, and here is B. I'm using AB because here we had AB. Okay, so our points here, so this is 5, and here I have 10. Now what I have here is 1 divided by B minus A, so that is equal to 1 divided by 10 minus 5, so it's equal to 1/5. So let's say here is 1/5. That is 1 divided by B minus A. Okay, now drawing it. Here I'm trying to draw a straight line. Okay, so that was part A. Now part B, what is the probability that reaction time is between 6 and 8 minutes? Okay, so probability when X is between 6 and 8. Okay, so based on what we had here on this part, we had 5, 10. Now on this part we have 6, 8. So here is 6, and here we have 8. And again we have 1/5. So this part is not changing. So what we need to find is the probability for this part between 6, 8. Okay, so that is equal to, here is 1/5, and the difference between 6, 8 is 2. So 1/5 times 2 is 2/5. Now, part of what is probability that the reaction time is between 5, 8, exactly same as the previous part. Now, area when X is between 5, 8. Okay, now drawing this one first. Here again, we have 5, 10. And then point that I have here is between 5, 8. And once again, here is 1/5. So this part we need to find the area between 5, 8 is this part. Okay, so this is equal to 1/5 times the difference between 5, 8 is 3. And the answer is 3/5. Now part D, what is the probability that reaction time is less than 6 minutes? So probability X less than 6. Again, 5, 10, and here 1/5. Now we have X less than 6. So we should find the area for this part, which is less than 6. So that is equal to, again, here is 1/5 times the difference between 6, 5 is 1. So the answer is 1/5. Okay, now here we have normal curve. What we need to know on this part is that Here we have class width. It's not clear to see, but here we have different numbers. And the point is that when class width decreases, these histograms getting closer and closer to this red curve. Okay, so I'm writing that. So when class width decreases, it's getting closer and closer to curve. Okay, now on this part we have an empirical rule again. But here on this part we're calling this normal distribution. So if you remember, here on this part in between we have mean. Then on this part is within one standard deviation, probability for that part is 68%. Within two standard deviation is 95%. And within three standard deviation is 99.7%. And the rest of it, here on left we have 0.15%, and same thing on right we have 0.15%. Okay, now based on what we have an empirical rule answering this part. So this is normally distributed when mean is 2,200. So mean is 2,200 and standard deviation is 200. Okay, part A, it's asking to draw a normal curve with parameters labeled. Okay, as I said, here in between we have mean. Here is mean plus one standard deviation. On the side, mean minus one standard deviation. Mean plus 2 times standard deviation. Mean minus 2 times standard deviation. And here is mean minus 3 times standard deviation. On the right side, mean plus 3 standard deviation. Okay, then I'm using these numbers here on this part. Mean is 2,200. Then mean plus standard deviation. Adding these two numbers, we have 2,400. And here is 2,600, 2,800. Because it's 2,200 plus 3 times 200, we have 600, plus that part is 2,800. Now here is 2,000, 1,800, 1,600. And one thing to mention is that here, as I said, based on this empirical rule, adding all these numbers, 99.7% plus 0.15%, and here also 0.15%, adding all these numbers, we have 100%. So the area starting from that point, till this point area is equal to 1 or 100%. And then here part B, shade the area on the normal curve to the left of x equal to 2100. Okay, so this is 2200. Here is 2000. In between, we have 2100. Okay, then part C, suppose that the area under the normal curve to the left of x equal to 2100 is 0.3885. So what that means here, the area for this part is equal to 0.3085. And it's asking to provide two interpretations of this result. Okay, the first one can have the proportion, which is exactly the same as area probability. Okay, so the proportion or part of the group whose weight is less than 2100, point is 0.3085. Another one we can say the probability of a randomly selected less than 2100 is 0.3085. Okay, now number 3, the graph and normal curve is given. Use the graph to identify the value of mean and standard deviation. Okay, so based on empirical rule or normal distribution, here in between we have mean. So mean is equal to 2. On this side, this is mean plus standard deviation, or we can use this one, mean minus the standard deviation. Let's use this. So mean plus the standard deviation is equal to 4. And I want to use that mean equal to 2 here instead of this part, mean. So we have 2 plus standard deviation equal to 4. Now finding standard deviation, subtract 2. So standard deviation is equal to 2. So the answer for this part mean it is 2, and standard deviation is also 2. So the center is at 2. That's why mean is equal to 2. And also the distance to the nearest empirical because here we use empirical rule. So that is 2. But that means standard deviation is equal to 2. Okay, so this was first part of this chapter, and later we'll work on part 2. Okay, bye-bye.